Or the second law, say distributive law, if I add the two matrix, so add B and C, and then multiply to A, it's the same thing as distributing A times B plus A times C. I'm sorry, it should be a plus here. Right? Just like number, right? If you have 3 times 2 plus 5, it's the same thing as 3 times 2 plus 3 times 5, right? Again, we're not going to go too deep to this. I just want to introduce you to the laws, that's all. All right, the story problem. Real estate. Bond Brothers, a real estate developer, builds houses in 3 states. The projected number of units of each model to be built in each state is given by the matrix. So here they have 3 states here: New York, Connecticut, and Massachusetts. Right? And then the Roman letter 1, 2, 3, 4, those are types of models. And so model 1, model 2, model 3, model 4. And these numbers here are the units, how many units they built for each model in each state. The profit to be realized for each model is 60K, 67K, 71K, and 95K for each model respectively. Part A, they want you to write, I'll give you the answer. They want you to write the column matrix B, represent the profit for each type of house. So column matrix means just a column, one column, right? It had many rows, but only one column. Column for the profit. So what should I put in this column? The price, right? The price right there, right? 60K. So 60,000, 67,000, 71,000, and 95,000. So far, so good. Part B, find the total profit Bond Brothers expect to earn in each state if all houses are sold. Now, it's just by logic. If you don't know anything about matrix multiplication or dot product, if I want to ask you what is the total profit, then what do you do?
Add them.
And before I add them, what do I have to do first? These are different price. So model 1 have a different price than model 2, have a different price than model 3, have a different price than model 4. So I have to multiply each these by the price of each model, right? So say model 1, I have to multiply with 60,000, right? Model 2, I have to multiply with 67,000. And then after that, I add them all up, right? And then I figured out what is my revenue. Now, let's see the revenue. We're going to use matrix multiplication. Remember the Costco example, the food court? Right. So I'm not going to write out the matrix. Let's see, this one is 3 by 4. This one is 4 by 3. You gotta be able to organize your matrix in such a way that is the inner dimension is matched, right? So I have to put in what matrix first. So here, I'm gonna call this matrix B. So I'm gonna put in what matrix first. Let me write down here. I got 3 by 4, and then 4 by 3.
Wait, how's that 4 by 3?
4 rows. I'm sorry, 4 by 1. My bad. I'm sorry. Thank you so much. I don't know where the 3 come from. Oh, I know, because I was thinking about 3 column. 3 by 4 and 4 by 1. Thank you very much. So which matrix come first? Matrix A, right? A times B, right? A times B. So 60, 20, 10. And then model 2, 80, 30, 15. And then 120, 60, 30. And then 40, 10, 5. Because that's a 3 by 4. And then times a 4 by 1, which is, I don't feel it right. I'm just gonna duplicate this one. The inner dimension is matched. And your final dimension should be 3 by 1, right? We're gonna use calculator for this one. On the exam, if I don't say anything, if I don't say do by hand, then you're allowed to use calculator. Especially like story problem. I'm not gonna make you do by hand. I don't want to use a calculator. A lot of time it make me nervous. So I'm gonna use decimals again. Let me take pictures so I can see what I'm entering. All right, you go to decimal matrix, just put in decimal matrix in Google, it'll come up with the link. So the matrix A is a 3 by 4, 4 column, 60, 80, 120, 40, 20. If I enter it wrong, let me know. 30, 60, 10, 10, again, 15, 30, and 5. All right, and then matrix B, let me delete that. Matrix B, new matrix, press new matrix. Matrix B is the 4 by 1. So 4 row, one column, 60,000, 67,000. Oops. And then 71, 1, 2, 3. And then 95. Right. And then A times B. There you go. Right. So New York, so that's how much they make for each state. So New York, they make roughly 21 million, right? Connecticut will be roughly 8 million, and Massachusetts is 4 million. Let me take a picture again. Copy down. Oh, good God, I can't see. Okay, I can see. I'm just gonna say roughly 21 million. Okay, 21 times 10 to the 6, and roughly 8 million. Is it 4 million for the last one? All right, something like that. Is it 8.5 something? I don't know, but it's roughly something. I don't want to go back, put in the little by entry, number by number. All right, not the point. So that is the story problem. Right, on the exam again, you use calculator. Don't do it by hand. You don't have to. Now for the last part, this is the introduction for 5.6. So far, can someone remind me how many ways I can solve a system of linear equations so far?
2.
2. What are they?
The elimination and the Jordan-Gauss method.
Very good. Thank you, Amaya. Yeah, 2, right? So, but today I'm going to introduce you another one. Probably going to be your least favorite, but don't shoot the messenger. I just gotta prepare you for the final. Now, on the exam, I'll tell you what I'm expecting, and you'll be glad. It's not hard. I'll make it very, very, very reasonable for your exam, but I don't write the final, so I don't know what's gonna be on the final. So I gotta show you everything, right? So anyway, matrix representation, using the formula AX equal B, where A is your coefficient matrix. Maybe I'll use red for that. It's a coefficient matrix. X is the variable matrix, and B is your constant matrix, as you can see, right? So here A will be what? 1, -3, 1, 2, 1, -1, 1, -3, 1. So A is just the coefficient of X, Y, Z, right? Coefficient of the variables. They call that the coefficient matrix. We talked about this before when I introduced you to augmented matrix. I don't know you remember. B is the variable matrix. I forgot the exact name in the book. I'm sorry, X, my bad, X. Here we have 3 variable. So the capital X represent little x, little y, little z. Right, so just column variable. So we just X, Y, Z. And they call this, I don't remember the exact name, but I'm just gonna call them column variable. It's not important that you know the names, it's important you know how to do it. And the last one is called the constant matrix. The numbers on the right of the equal sign. So here in this case, it'll be 1, 2, 1. The constant matrix. All right. And later, we're gonna learn how to solve for X, Y, Z using the inverse matrix. But that's 5.6, right? Well, we'll get there. We'll get there. But that is matrix representation. All right. Yay, we done 5.5. Let me